Maurieo explains bearing close example number 002. Coming up, a chance to get a screen grab of the clean worksheets so that you can have a go yourself and work through the answer with me if that's what you want. All good. Let's get on with the show. Hello, Maurieo. I have been asked to take a look and explain this close example here. So that's what I'm going to do in this video. So this is the model answer or an answer to the worksheet, which is obviously the written content there. So first step is to close the bearings. So what we've got here is, I guess, raw adjusted bearings here for each setup. So above this would be all your readings, face left, face right, and all that. So these are the final ones. So as you can see here, we've come through 257, 1150 is our origin. And we have observed down to here to iron tube 1, 154.01.44. We have then come here and set the reverse back bearing 334.01.44 and got 181.43.27 to iron tube 2. We've then come to iron tube 2 and set the reverse bearing there of 1 degree 43.27. You'll see they agree there. And observed 144.57 down to iron tube 2 SO 25687. Right, and then we've come to iron tube 2 SO 25687 and set the reverse bearing 324. That's probably a better way of saying it. 324.50.57 and observed 21.30.50 to iron tube 3. But iron tube 2, you'll note that they're old iron tubes because they've got the black centres, is a bearing that we know to be 21.30. We, however, carried forward this bearing to get 21.30.50. So we have a bearing misclose of 50 seconds. Now we've got 1, 2, 3, 4 setups, 4 angles. So that is a bearing misclose of 50 divided by 4, which is 12.5. I don't usually go to points of a second. I seem to have done that here. I would normally go 12, 13, 12 or 13, and then 25, maybe 37, 50, something like that. So keep them to the nearest second. But I've gone to the nearest 0.5 here and then rounded it all out at the end. So that's 50 seconds to be subtracted is minus 12.5, and that gives us 154.01.31.5, and then minus 25, so we're adding minus 37.5, so we sort of just apply 12.5 seconds per setup, but we've got to bring everything gradually round to 50, and so there it is, 12.5, 25, 37.5, 50, so that's 12.5 seconds applied at each angle. Then that gives us our adjusted bearing, and then we round them to the nearest 10 seconds. I've done in this case here. 154.01.30, 181.43. No, these should be the same. The same. Then having rounded the bearings, I then write them on the field diagram, which this would be. I would call this the field diagram. So they get written on there. And the distances have been confirmed that they should be the same as well, like that there. So, and that should all be written in there. So then we go to page 2. So from the diagram, we key in the bearings, well, key in the marks, IT3 to IT1, IT1 to IT2, IT2 to IT2, SO 25687, and so on. We put in the bearings from the diagram, rounded to the nearest 10 seconds. We then run out these here. Now I'm working, in this case, I've worked to the nearest 0.01 here, so the nearest centimetre. So yes, so we run these out. Remember, it's the cosine of the bearing times that goes here, the sine of the bearing times that here. So when I add up now, oh yes, so this is a link traverse. So we have a known coordinate here and a known coordinate here. So first thing we must do is work out the difference between the known coordinates, minus 162, and that's what we should be getting here, minus 162.45, and we got 162.48 when we add them up. So we must add 03 so that these are exactly equal, and here similarly we must subtract 04. Right, and then we apply them. Now we can use Bowditch, but in this case here, they're all very much the same length, very much the same length there. So I've gone 01 per there because Bowditch is proportional to the distance. It's just that divided by the total multiplied by that, which is, so they'll all be roughly the same. And we've got 4 to distribute here, so the extra would go into the longest line. But usually in test and exam situations for this topic, we go to the nearest millimetre, in which case we must use the Bowditch adjustment, which, you should become familiar with. Right. So then we apply our corrections so that if we go, I'll just do the northing, or same for the easting, that minus that plus that should give that, minus that plus that gives that, minus that plus that should give that, and it should equal the value that you're given, should equal the known coordinate. Same for the eastings. Right, so now let's look at the misclose, and we can see here that the misclose, in this case, we've got to go, to get back home, or to get to this one here, we've got to go the opposite. So it's -3, which is down, and +4. It's the opposite to these. It wouldn't matter if you had them, as long as you're consistent. So if you had that one positive and that one, if that one negative and that one positive, and well, that's what I've done. If you used the positive and the negative here, you would still get, well, you should still get the correct bearing, but it would be 180 degrees different to this one. Okay, so one's, just 180 different, which to surveyors and things doesn't, in this instance, not particularly significant. It's helpful to know which direction the misclose is in, but typically surveyors mix and match very quickly between 126 52 12 or 306 56 12. doesn't matter too much. It is important that you get it going the right way here, but not so much here. So I've gone with -3, 4 in this little triangle here of the misclose. So we draw that up. This is our resultant, or the misclose vector. We can use Pythagoras, 3, 4, 5. 3 squared plus 4 squared square root of is 05. And the bearing we want is this bearing here, clockwise from north. Now, we can work out this angle here, which is tan to the -1, 04 over 03. And then we can subtract that angle from 180 to give us our bearing of our misclose, 126, 52, 12. So once again, if you draw the diagram, you get it right. All good. So yeah, hopefully that clears that up for you, and yeah, we'll see you again in another video. Bloody marvelous.